Good afternoon, everyone. In the today's session, would like to review regarding the depth configurations related to the cutting parameters during the machining processes. Any kind of the machining processes is considered. For our instance, so far we have been learned a different machining processes such as a drilling machining process, its types, and better advantages, working methodology, and its internal process. And the shaping process we have come across the basic classifications regarding it and related to the working methodology as per the types of modes. What are the different types of machining characteristics that it is having, etc. We had a detailed discussion regarding it. And coming to this milling machines, we had a detailed look regarding the classifications, types of milling machines that are existing, flexibility related towards the universal kind, and horizontal mode of working and vertical mode of working. And finally, accessories in the milling machines and cutting speed and feed. With respect to that, depth of cut. So we are having in the today's class also. It's a basic phenomenon. Basic phenomenon. That is having the cutting parameters, how majorly it affects over the machining conditions, based on the machining conditions. And indeed to attain the particular dimensions as per the requirements, what are the basic features need to be considered related to these cutting parameters? We'll be looking after in detail. Initially, coming to the selection criteria, cutting parameters, selection criteria. So why we will be selecting this technique? Nothing but indeed to achieve the better surface finishingness, which gives a glance of appearance such as a finished level of product. Because if the machining process has not yet done in a confined manner, the layering aspects. So we are layering aspects in the sense the application of polymers, nothing but painting activities for the uh, ambiguity, nothing but for a glance orientation, will be affected and will be clearly specifying its non-linearity at different phases. At different phases. That what are the major parameters that affects it, and what are the basic features need to be asked for getting the high quality. Moreover, almost we all aware that the demand oriented products will be definitely satisfying with respect to the both quality as well as the quantity aspects. Coming to the point of these operations, different kinds of operations will be chasing them with one by one. First one, it is a roughing. Roughing is a technique which is used for removing the possible material from the workpiece, that too in a maximum MRR rate condition. So when competing with respect to the another strategy, that is layer by layer removal of the material with good finishing nature without having any of the BUE concepts, that is build up edge sectors, which forms an uneven layers over the surface finishing. My Moreover, it will be getting occurred in the case of this roughing technology. For that, the surface finishing is non-linear in the sense we are missing with respect to a finishing factor. Hence, if at all the finishing is not at all confided, quality will be getting affected. That's what the basic terminology that we have to understand. But in order to increase the demand, initially we have a detailed discussion regarding the demand. A demand in the sense it has to obey with respect to both quality and quantity, and then automatically, as per the demand, the economical point of view also it is very much feasible. Hence, this quality plays a major role that is lacking in the case of this roughing operational process. So for that, another one more process that is necessary, that is finishing process. So this is the major operational sequence that is progressed over the work parts in order to achieve the perfect dimensions. Nothing but just now we have been discussed that in the case of roughing we will be getting the non-linear structures, those will be getting minuted in the case of this finishing. So perfect dimensions will be getting identified with respect to slight tolerances, nothing but a feasible limitations, allowable limitations in the case of our objects. Hence, the quality plays a major role here. Again, quality is the best consideration need to be identified. How we'll be having a detailed look now. The basic feature, that is any kind of the business activity is progressed because of the factor that is earning of profit. Earning of profit. So how we will be getting earned those profits, more and more profits. So in order to get that, the variables such as cutting time during the machining process and cutting tool expenditure, these two are basic phenomena in order to chase in the aspect of the profit level. Second thing, it is machining parameters that affects the some variables related to the cutting time and the cutting tool expenditure. So what are those features? Those are nothing but the machining parameters, such as the cutting speed, cutting feed, depth of cut. So these three are the basic cutting parameters, we can say cutting parameters, that which decides the cutting time and cutting tool expenditure upon the coefficient of friction that is being developed by the tool over the work part based on the feed rate supplied or depth of cut given and the speed that is being operated over the work part in order to get the perfect dimensions. So here in the tabular column, it has been clearly specifying that VC is nothing but the cutting speed, and FZ, Fn, and F, that is towards the axis and n number of axes with respect to a particular feed. In the case of both the aspects, that is a roughing condition and finishing condition, that we have a detailed discussion presently. So how it will be getting achieved? There's a big question mark. So what are the speeds to be maintained in order to support with respect to the feed rate and to achieve the perfect dimensional accuracies with slight tolerances deviations in the case of this cutting time and cutting tool expenditure? That leads in order that limits to a maximum extent, and same materials has to be supported for getting the high quantity of products to be manufactured and with respect to safety precautions considerations. How it will be getting as we will be having a look. See here, first thing it is cutting speed. So cutting speed in the sense today here we are having two different types of machineries. One, it is work part will be in a fixed strategy and tool will be moving over the work part for machining activity. And the second thing it is work part is movable upon fixation and tool part will be in a fixed strategy. So we are having two different considerations here. And second thing it is universal in the sense it will be having the statutory operating parameters, whereas this horizontal will be getting varied and the vertical will be getting varied. So in order to get the particular speed or n, there is nothing but spindle speed. The two linearly when the tool part is having a contact with respect to the work part and processing the MRR condition, processing particularly the MRR condition. So for that we have a formula in order to find the spindle speed, that is n is equal to cutting speed into 1000 by pi into diameter of the machine. So here the machine in the sense the work part which is need to the machine. Right. Secondly, the cutting speed. How the cutting speed will be getting varied. Initial, see here then is a front view of representation where the work part will be altered with respect to step cutting process during the step cutting process with the different diameters. Step cutting is nothing but the different diameters. So that is D1, for example, it is 50 mm, D2, it's taken diameter as 80 mm. So initially we are having this 120, moreover this 80, there is 90 mm of diameter. Let us say for our instance. So for D2, it need to be decreased to 80 mm. That is nothing but 10 mm has to get removed. And for getting this 80 mm up to a particular length, that too for a particular length, that is for 30 mm at the case of this diameter 1 and 20 mm in the case of this diameter 2. Let's for instance we can say. So you need to identify the here also the cutting speed, diameters, n is equal to that the spindle speed measurements, or here the cutting speed measurements is VC, and in order to identify the spindle speed VC into 1000 by pi d. Same formula. Coming to the feed point. Coming to the feed point, there is feed. What is meant by feed? It's the relative movement between the workpiece and the tool. First one. When the tool has got engaged with respect to the work part, upon the MRR condition, that is nothing but material is getting removed in the form of a chips from the work part. Considering in a turning process, normally we have to analyze that how much feed per revolution will be getting consumed by the tool, how much depth for removing the material, either it may be of 1 mm or 2 mm, 3 mm, 4 mm, that will be getting identified. Second thing it is how much feed is getting agitated for each and every revolution that is being caused by the spindle that which holds the work part. So whether it is considering throughout the length of the material, for example, see here, throughout the length of the material or not. So if at all, not at all, considering for an static speed, then the finishing levels will be getting varied. Even second thing, if the feed levels also getting varied, then the surface finishing also will be getting altered. Third one, you need to confide that feed F is equal to feed per revolution into the spindle speed. So based on that, we can calculate the feed per revolution. So feed is nothing but certain material which is removed at a mm range per each and every revolution is called feed rate. Third one is the cutting depth. Cutting depth. That is how much depth in the case of this material removal by considering the feed agitation is processing. In the pictorial representation, we had a detailed discussion that this is the AP and this is the original diameter and this is the length and existing diameter. For example, it is 40 mm and we are having 30 mm and hence 10 mm of the material is removed by considering a feed rate per revolution. So for example, 1 mm in the sense, so 10 mm has to be removed that and hence from when the tool that is being starting from a movement from this edge point to a particular length, this is the length of MRR condition. It should be happen for getting removed that too for 10 times if at all it is 1 mm of feed rate. So if the depth of cut has been varied, the feed rate conditions has been increased, the depth of cut will be possible in 5 different sequence of operations itself. And we are having different kinds of mating conditions also here. There is straightforward cut and facing operations, counter positions of cutting, stepwise cuttings, and different at levels of positions. See here, we are having need to get the slot considerations and facing operations after getting faced, and here the step condition. This is the initial step. Secondly, the facing operations, and thirdly, the slotting operations. Only removing of the material other than the diameter to a particular extent. In the case of turning, for the type of materials, that too for different kinds of operations as a standard table or column, what are the cutting speed, feed, and depth of cut to be maintained as per the formulations we can calculate. And for some of the materials which will be widely utilizing in the society, we are having some of the details here, and these are the standard values that has been obtained from the ASTM standards. That is American Society of Testing Materials. See, in the case of this turning machine for steel, so steel composition materials, nothing but iron composition materials, and that also at a high grade and high strength materials, that is high speed steel, and next one is hard metals. And for the high speed steels, considering turning and facing operations, and that too of maintaining the speed, that too for 30 to 40 diameter, and feed rate that is maintained for the up to a diametrical stage, that is 0.1 to 0.25 mm, and depth of cut 0.75 to 2 mm of range. Second operation is parting and grooving. For that, 10 to 15 meters per minute, and feed rate 0.02 to 0.1. Considering the threading 10 meters per minute, feed rate, thread pitch, and as per the formula that we are having, n is equal to calculations, identifications, and upon cross verification, cross calculations, simplification process of the same formula, that is Vs into 1000 by pi into d, we can ascertain that formulation for identifying the speed, and indeed to that upon substitution we will be getting this depth of cut, feed rate, and by substituting both the speed and feed we will be getting this depth of cut. And simultaneously for the drilling operation, for knurling operations. Coming to the steel for hard metals, turning and facing, parting and grooving, we have different speed, feed, and depth of cut values, parting and grooving, threading activity, drilling activity, and boring activity. For aluminium, high speed steel, hard metal, if you have been utilized these materials as an tools indeed to operate on the aluminium material. So that too for different operations such as turning and facing, for about diameter of 40 to 60, that's maintained of 60 to 80 meters per minute. That to feed rate 0.1 to 0.25 and 0.0 to 0.1. Considering this depth of cut 0.75 to 2 mm and 0.2 to 0.8 for straightforward cuttings. That too for initially it's on straightforward cuttings. That D refers to, and facing operations refers to an accent positions, accent marks. Threading activity 15 meters per minute. Thread pitch need to be specified. That will be calculating as per the standard formulas that we are having. Simultaneously drilling, knurling, boring, and for hard metal, if you have been utilized a hard metal as a tool, for that the turning and facing, a nominal speed need to be maintained, speed maintained, and depth of cut need to be ascertained. These are the then standard formulations that are being considered. During the turning process, the basic phenomena, that is the surface finishing and We'll be having the NDE subject in the next year, non-destructive evaluations, that without disturbing the object indeed to verify the surface finishings, depth considerations, different flaws of irregular sizes, casting defects, welding defects, so etc. During the machining process, what are the different dimensions deviations existing that can be clearly observed. Considering the cutting parameters turning regarding the facing operations, fixation of the tools, as the depth of cut maintained towards the straightforward cut, and is the facing operations related cut. Vibrations. It is the basic phenomena that will be getting attained during the machining process because of the types of tools and its tip engagement and variation. Upon variation of these cutting parameters, vibration is the major considerations that need to be happened, and which destructs the slight range towards the work part dimensions, and mostly it gets affected for the tool parameters. There is nothing but tool will be getting highly friction in range, frictional effects. It leads to get the frictional effects and flank work. It leads to the work conditions at a maximum range of commencing these vibrations. Moreover, these vibrations depends upon or vibrations that will be getting controlled by these dampened tools. So rubber springs will be getting attached over it. If at all those vibrations has been created, these rubber springs will be absorbing that damping sections, and tool will not get deformed in its work progress. Hence, a perfect finishing will be getting achieved. Coming to the point of this milling, simultaneously the same parameters that will be getting answered for his, and same formulation is used for cutting over this machinery. But in the case of turning, we will be having a horizontal orientation of work. Basically, in the case of this milling, will be having a tool fixed. In the turning, tool is getting varied, work part is fixed, as we have been discussed initially. Here, in the case of milling, the work part is movable and tool is fixed. And upon that, the feed rate, speed, and depth of cut need to be analyzed. Nothing but the relative motion between the work part and the tool. And how much here the milling tool is having a tooth considerations. So how much feed has been given, and based upon that, the chip thickness will be getting elevated. So I will be identifying this feed rate per revolution, the tool displacement per tool revolution. Nothing but here Z tooth number, nothing but a flute number, n number of teeth that are having in a cylindrical agitation of the tool. So in order to find out the feed per revolution, Fn is equal to Fz into T, number of flutes into Z. Correct? So feed per minute will be getting calculated upon the formulations. And depth of cut, it's machined over the work part. So machined over the work part by sliding the work part as per its axial depth of cut, that is AP specifies the axial depth of cut, material which is at removing during the machining process of the, in the case of this milling actions, and radial depth of cut, nothing but radial depth of cut. It's also get progressed based on the side change or fixation change of the work part. See here, fixation change. Material that's being removed by the tooth upon the engagement of work part over the material. Coming to this point, the standard values in the case of this milling process, that too for workpieces like steel and aluminum, most widely utilized in the tourism sector, and corresponding tools which are used for machining over these steel parts and the aluminum parts, and concerned operational process, that is face milling, side milling, other milling, the two phase milling, side milling, and other milling in the case of this hard metal steels, and over the aluminum process, high speed steels. If you have been list, what are the speed, feed, and depth of cut need to be maintained for the both of the aspects. These are the standard results given in the tabular column as per the ASTM standards. Cutting parameters, as we have been already discussed, that in the case of this left side movement, the unitary actions will be getting taken place. That large chip thickness will be at a starting zone, and upon ending zone, it will be getting decreased. Frequently, it will be getting decreased. And upon this upmilling process, in the case of down milling process, it is a greater advantage. And in the case of this down milling process, upmilling process, it starts with slow initial movement of elevating the chips, and at the end process, it will be elevating a maximum thickness. Nothing but as like of the built-up edge, right? That's of because of the frictional variations, and thickness of the chips will be getting varied. Coming to the point of this high speeds machining process, spindle speed should be increased, and it should be increased. Axial depth, almost all the parameters should be increased. So for that, what are the factors having, and what are the effects based on it, and what are the benefits regarding it? High speed machining process. Thin chip thickness will be getting achieved, and the effects are low cutting force per deflection, and the basic better benefits, deeper axial cuts will be getting asked here. In the case of the small arc of engagement, it reduces the temperature at cutting zone, because the temperature need to be increased in order to elevate the temperature with a good surface finishing. And better benefit it is having the high speeds. High speeds. Nominally, in the case of this trochoidal milling, that is high speed machining process, progressive cutting, constant peripheral cutting speed. These are the pictorial representations where it's getting widened in the case of this milling process. Coming to its characteristics, it's more productive cutting process. That too in the case of the small sized MRR process, possible to use high alloy steels which are having up to 60 to 63 HRC by avoiding the EDM process. Having the excellent surface roughness, even the machining condition is possible over the very thin walls. That is the typical application orients, that is dies and molds, difficult to machine the materials. Coming to the Disadvantages with respect to the high speed machining process. Good work and process planning is necessary. Because of that only you will be getting the benefits. Machines with safety in person, avoiding long overhangs of tools, specific process knowledge. It can be difficult to find the recruit advanced staff. These are some of the, I think, but the skillful workers are necessary here, and that will be a bit difficult in order to recruit those persons, because in the economical point of view also it's a great burden towards the persons. These are the sum of representations regarding the milling process for achieving the better considerations. Strategical cutting points, right? These cutting parameters and strategical process will be discussing in the next class. Thank you.